Good afternoon, participants. I'm very much happy to welcome you all for the afternoon session. Uh, Now, the session is going to be handled by the Aruna Devi ma'am. Ma'am,
Yeah. Good
yeah, you
evening.
can continue.
Good afternoon, everyone.
Good afternoon.
So now we will see the implementation of VGGNet using the Breakers dataset. I'll share the slide to. Is it visible? Is it visible? Dr. Pradeep, is it visible for everyone?
It is visible, ma'am.
Okay. So today in the practical session, actually I'm going to explain the things how it will run for the VGGNet 16 and I'll show the code for the ResNet 50. I'm going to use the dataset, Breakers dataset, the 100x magnification. We have 4 magnification. For this example, I'm going to use only the 100x magnification. So in this dataset, we are having 2 classes, that is benign and malignant. As I have already mentioned earlier, that is benign for the non-cancer and the malignant represents the cancer images. So I advise you to refer this GitHub page because I have taken the examples from this page and I'm going to explain with you. And if you want to apply the Stein normalization for this histopathology images, you can refer this web page. You are having a Python implementation and you can use it, okay? So we'll start. I'm going to explain the things in Jupyter Notebook. One second, Pradeep, I'll go and open the.
Yeah, okay. Nice.
Are you able to see my screen of the Jupyter Notebook?
Yeah, it is visible.
Okay. So I hope you are aware of when you are developing a deep learning model, then you will be using the Keras or Torch. TensorFlow, you will be using Keras, and Torch also, PyTorch also you can use. I'm familiar with the Keras platform. So I'm using Keras for implementing the VGGNet. We are having, actually I want to, finally I'll show the web page that is, I took the code and everything. And from the starting, 2017, I started my research when I was doing this web page that guide me a lot to carry over and observe the things. So I advise everyone who's new researchers that they can benefit from this web page. And he will clearly explain the things in video also, if you subscribe this his video. Okay, so the Keras platform we are using for uptime. These are all the Keras Python library. We have to use it for the convolutional neural network implementation of VGGNet. I'm importing the VGGNet and we are having a file already, VGGNet. It is having the implementation of the details of how many layers and how we are giving input. Then we are having another files, that is a Python library for importing the dataset from our, that is we want to use our custom data, that is our data, then we have to use it from our own system. So you have to use these libraries, that is the computer vision and the OS libraries. Okay, and if you want to use the metrics and you can use the, if you want to use the classifiers and you can use the Python library, that is scikit-learn, it will be very comfortable to give and analyze the metrics. You'll be having a lot of metrics to measure your performance, like confusion metrics and AUC, accuracy, sensitivity, specificity, precision, recall, everything. It will be, you can get the metrics values. Okay. So I'm going to load my data for training and testing. I'm going to load it from the folder, that is I have stored my 100x magnification scale in this folder. So first I'm giving the path. Okay, then I'm going to get the data path that I have stored in the C disk. If I want to, Actually, only my screen is visible to everyone. Excuse me.
Yes, ma'am.
Actually, okay, I want to show the images. Okay, it's okay. So the folders, in the folder, I have a benign folder and malignant folder. Okay, in the benign, I have some amount of images, and malignant, we are having some amount of images. Then I'm going to, so the number of classes I'm going to use is 2. You can rename it. If you are using 4 classes, you can use 4. Okay, I think the Anusha, the web page which I'm referring, he is using 4 classes. I hope so. So benign, I'm assigning 0 label for the benign category and 1 for the malignant class. Then I'm going to create a list for my image. Okay, it is according to my convenient. I have labeled these variables. Okay, you can use your according to your convenient. So for image normalized list, I have created a list for storing the image, and I'm creating a list for storing the labels. Then this for loop, it will retrieve each images from the data set and the path. Okay, then the data set label, according to the label, it will be assigned here. So image list, it will directly retrieve the images. Then for each image in the image list, for this image list, one by one, we will be giving it as we are reading the images and we are resizing. Here I'm going to use VGGNet 16, so I'm going to resize the images since the size of the network which will accept the input 224 cross 224. If you don't want to resize, you can use the patch extraction and you can extract the patches from your images. Usually the advice for the medical data, medical images, you should not resize. Here for the practical, I have given resize. You can use the patch extraction library functions to extract the patches, then you can feed it. Okay. Here I have resized the images 224 cross 224. Then in my list, which I have created here, okay, so I'm appending the input image. Each image will be attached to this list with its label. So according to its label, it will be attached to this list, to this 2 list. Image data will be having the image and label will be having the label for that particular images. Then I'm doing the normalization, like I'm making it as a divide by 255. As I hope you know that our images will be containing the pixel values that will vary from 0 to 255. So I'm making it normalized. Then I'm making the labels to categorical. That is the vector to you are having a vector and it will be to a binary class. So I'm having totally 2081 images, both benign and malignant, and it is the size of 224 cross 224 and 3. I hope you can refer this 3 represents the channels, that is RGB. Okay. So when you go further in deep for the first hidden, second hidden layer, these things will vary according to your number of filters. Then I'm going to split. These are the details which is not necessary actually. The main thing was here that we are going to split our data set. Okay, we have to split training and testing data, or you can say training and validation data. So you have to use the package that is from scikit-learn. This you are importing this library, and you have to define like xtrain, xtest, ytrain, ytest. Then this function you have to give the input of total number of images and its label. And the test size, you can change this size according to your, mostly probably 70 and 30 will be, they will separate, that is a 70% of data should be as a training and 30% of data as testing. And another common standard they will be using as a 80-20. So you can here 20% means if you make it as 0.2, then 20% of your data will be allocated as a testing. Okay. So this is the train and testing. So we are going to use 1456 in the size of 224 cross 224 for the training, and this 625 total number of images for testing will be 625. Okay. Then I have imported. So our image input will be in the size of 224 cross 224. Then I'm placing my model. So then I'm going to when I run this, you can observe here. 1 second, I'll show you. So when I make the summary here, model.summary, initially my model VGG16, this is my layers and this is the output and the parameters, that is the weights, how many number of parameters they were using. You can see the fully connected layer, last layer with the 4096 neurons, and the fully connected layer 2, it is with the 4096 neurons. The predictions, it is for 1000 classes, okay, because it was pre-trained with the 1000 classes for classifying the 1000 class. Then what we are going to do is we are going to freeze some of the layers and we are going to train for our medical image, that is the Breakis data set. There is a histopathology images, okay. So the last layer which we are getting, and we are going to make changes in the last layer. Here for the first model, I'm going to change only the class final, that is the I'm going to change 1000 classes. It was there. So I'm going to change it to 2 because our classes, number of classes in our example is 2. Okay. So the dense layer, the activation functions which we are going to do, we are getting the output from the last layer. So the last layer will be trained. So -1, we are going to change the final layer. Okay. Then they will train these layers, and you do the compilation. You can use different types of loss function. Here I'm going to use the sparse categorical cross entropy. And the optimizer also you can change, you can vary accordingly. For some of the problems, RMS provocation will be giving good result. For some of the problems, according to your data, it will vary. You can try with the stochastic gradient descent SGD. Okay, the metrics we are going to check, it is the accuracy. I'm going to calculate the time, how much how long it will be executing. So this is for compiling. We are going to compile our model. We have changed our model. Okay. Then we are going to, here actual training is going to happen. That is VGG model.fit xtrain, our training data, and its label and the batch size. It is 32 number of images will be trained for each, and it will be taken again another 32 number of images. Then epochs I have limited only to 2. Okay. Actually, mostly when I was doing research, I observed that until 25 they were doing. And if you are having a high GPU computing, you can try with 100 and 300. If you're increasing your epochs, sometimes it will increase, and you have to check where it is stopping. You have to observe the result. Okay. Then the validation data. Actually, we are giving this X test and Y test. Okay, that will be considered as our validation data. Later on, you can give other data to testing also. Okay, when you train this model, here we have only 2 things, the training data and the testing data. So loss and accuracy we are going to observe. This model, the model which one we have defined here, it will evaluate it will train this images, and it will test the data, and it will print the loss and accuracy. Then again what I'm doing was, I'm going to change the last 2 layers. When you have observed the dense layer, it was having 4096. Sometimes we want to reduce the neurons like a dropout. Okay. So I have reduced the neurons to 128 neurons. We have changed, we can change. We are getting the input from the final flattened, that is a fully connected layer. And we are giving and changing it. The neurons will be, number of neurons will be changed to 128. And our model is defined. Then we are going to train with our images. Okay, here you can see that earlier I was using the RMS propagation. Here I am using ADA Delta optimizer. Then I'm going to train the model. The model is trained here, and the same batch size and epochs will be using. And the model is evaluated with the test data. So we can see the changes. So here I'll show the example. Here for the first VGG minute model, I have explained that I have changed only the classifier, that is the classes, number of classes. Okay. So when I'm when I'm training with that model, I'm getting only the accuracy of 43 and loss is heavy. Okay. Actually, it should be less than 0.00. When you are increasing your epochs, you can observe the changes. So here, in the second model, I'm going to change the dense layers and I have reduced the neurons and I'm training. Okay, I'm training. So there is a little improvement and the loss is little bit reduced from 0.8 to 0.6. Okay. So this is the difference when you are changing the when you're reducing the neurons, you can apply dropout functions and you can see the changes in the performances. So I'm going to try I'm going to observe other metrics. So I'm again training with the second model, which we have changed the neurons and the classes. So I'm going to obtain the confusion matrix. Okay. So I have the prediction from the model, and y-test, it refers to the label which it was labeled like benign equal to 0, which we defined. The images which is in the folder benign will be the images which is under benign folder, it will be labeled as 0, and those who are in malignant folder will be labeled as 1. Okay, so this is the real target and the predicted target will be obtained from here. Then we are going to print the confusion matrix here due to the since actually we need to extract the patches and do for medical images. Here I have resized one of the reason, and when you increase the epochs, it will increase the performance. When you see this is the confusion matrix, actually the benign, the class 0, it is mostly labeled as the malignant. That's why we got the less sensitivity and specificity like this. Almost the malignant part is even the malignant part is correctly identified, even with 2 epochs. And we can use the scikit-learn for observing the other metrics like precision recall F1 scores. So you can use this metrics to show the performance of your model. And some of you might have heard this Cohen-Kappa score and Matthew correlation coefficient, and you can observe these things from the scikit-learn. Okay. And also for the AUC curve, here within our 0 label was identified very less, so we are having only 0.50. If your model is good and trained with more than 30 and 50, maybe my model, it will be giving AUC of 0.75 or 0.80. Okay, this is the code for obtaining the ROC curve. Then I just tried with the other things. Here, actually, I'm having a code for ResNet. When I try, it was not working. And one more thing I want to share is, 1 second, I'll stop this share. When you are you can download these codes from that website, which I have given in the PPT. But make sure that you have to make some changes with this ResNet and VGGNet file. I'll show you where you have to make the changes. Now I'll close this and I'll open that file. Are you able to see this screen?
Yes, sir. No. Yes.
Actually, due to the Keras updation, you will be facing error when you are when you are downloading the folder and executing the program. So you need to check that you have updated these 2 lines. Okay, I'll attach the code and data set and these things and update with the Dr. Pradeep. You can use it also. Okay. So these two codes you
Yes.
have to keep it in your mind. You have to change it. Okay. Then another part is you have to change it here. This will be like include top. So you have to change it to require flatten. Okay. Because of the Keras updation, they have changed when you, if it is include top, then it will show you the error. So these three modification you have to make it in VGG 16 and ResNet 50 program. So in the same way, we are having the code for the ResNet 50. I have imported the ResNet 50 file, and there is I'm going to load the model. So here, in the same way, I'm going to use and change the last layer for the classifier. I'm going to use the two classes, so I will be changing the last two things. But further in the second model, I have updated here. You can see there is a dropout function. You can 50% of neurons I have dropped. I have changed even though 512, but during the training I want to drop some of these things, so it will avoid overfitting problem. If you have a less amount of data, they will be using this dropout function, which was proposed by Sivu Vastava, and you can use this. Okay, so here I have changed the Atom optimizer. Here there is a error I have changed, but still because of the short duration I could not run it again, but I'll run and update it with you in the folder, so you'll get it, the final one. Dr. Pradeep, I think I finished with this. Dr. Pradeep?
Yes or no?
The practical session which I was prepared for only for this
Okay.
classification task.
Yeah,
Yeah.
okay. Can you give some platforms to learn the deep learning for the participants? Can you show?
Yeah, I think actually one
the-
second.
Yeah.
I have shown the, I will show the PPT. One second, I
Yes,
want to show the other things so that you can have lot of examples for the recent advanced techniques, and you can use it, customize with your own data. I'll place in the PPT and I will show it now within few minutes.
Yeah.
Are you able to see my screen? Here there is examples that you can get for all the new techniques, and for even for, this is for computer vision task, and if you are doing under natural language processing, you can use this, and audio data, whatever you are going to use, you can reinforcement learning and graph data. Nowadays it is very for using the graph for neural networks, so you can observe the things and you can modify and make it use for your custom data. And another one which I referred was this web page, that is Anusha website. You can download the things, transfer learning in Keras. You can download all the files. Only thing you have to modify this file and this file that I have shown, that if your Keras is updated, then you have to make the the changes in those 3 lines. Thank you. Thank you for your time, for listening my lecture. I have to thank everyone for giving your valuable time. Dr. Pradeep, I
Thank
think,
you, Aruna. Yeah, thank you, Aruna. It's very wonderful session. You being eye-opener for the new researchers, for the new dimension, and already who's going in the your path, they definitely getting the some amount of knowledge extra. Okay.
Okay.
Dear participants, do you have any kind of query in the sense you may ask now?
If there is no queries, then I think we can wind up, Dr. Pradeep.
Ma'am,
Yeah.
Yes.
ma'am,
Yeah.
this is my point of view questions, ma'am. If any mistakes, then you can. First of all, I asked sorry, ma'am. Ma'am, this is my point of view. For if you want to propose anything during the research work in PhD work, we have to change the logical parameters, or
Yeah.
otherwise, yes, ma'am. Logical parameters in deep learning, one of the default layers that the structure is there. We have
Yeah.
to modify the structure of
Yes,
the particular
yes. Yeah.
model.
Yeah, yeah.
So change the structure of the particular model in the sense we have to for a downsampling and upsampling, or otherwise in the layer wise we are changing, or otherwise we are adding some layers. That's all the proposed work.
Actually, no. Actually, we have done modification in the filter learning task. My proposal was PhD was we have derived a new mathematical model for learning the filters. So it is like you have to propose a new model, but I have suggested these examples for the bachelor students that they can get a experience with the
Okay, ma'am.
examples, and they can change. They can play with the Adam optimizer and they can
Yes,
change
yes.
for learning purposes. But
Yes,
for the
ma'am.
PhD researchers, students, those who are doing masters, advice is you have to change the architecture and you have to make some changes, and you have to propose some optimizer or some. You have to think about how we can reduce the global minimum. You can attain the global minima in whatever way you are changing in your model architecture. You have to change. As a CSE student, we have to.
Okay, ma'am.
Yeah. Thanks for your
Dear
question.
students, yeah. Dear participants, any other questions? Otherwise, we can able to wind up the session. Thank you, Aruna. It is a wonderful
Thank you.
session. You're giving a very great session for us, for the participants too. I'm very much happy to have you as a resource person in this session.
Thanks.
This is the time for the feedback. Any participants? You give a oral feedback in the sense? You can come forward.
I think it is almost afternoon. They want to go.
Yeah. But dear participants, I will share the feedback link to the mail already. Okay, I will enable the
Already you
link.
shared the feedback.
Yeah,
link,
yeah.
But it is not
Yes.
accepting responses, I think.
Yes, ma'am. Yes, ma'am. Yes, ma'am. I disable now. Okay, now I want to go into enable now.
Okay, sir.
Okay. After the completing session, I'm going to enable
Okay,
the
sir.
link. Okay, no issues. Okay. Okay, thanks a lot for the wonderful session, Aruna. And the participants, we are grateful for you for the whole day. You're giving a wonderful support for us. And the link is already available in the video is already available in the YouTube also. You can refer that. Thank you. Thanks a lot for the cooperation. Thanks
Thank
a
you
lot.
for that.
Aruna, thank
Thank
you.
you, sir, and thank you, ma'am.
Thank you. Thank you so much.
Thank you, sir.
Thank you, ma'am. Aruna, I will catch you within 5 minutes. Okay.
Okay, in the this Microsoft team or
Yeah, another 15 minutes I will call you.
okay. Thank you.
Thank you.